Have you ever been in the middle of an important task, deeply focused on your computer, when suddenly your application freezes, shows an error message, and then completely disappears? That abrupt, frustrating moment is exactly what we are discussing today. A software crash is fundamentally defined as the unexpected and abnormal termination of a computer program, or its complete unresponsiveness, which results in the loss of its normal execution flow and functionality. This usually means the program ceases to operate as intended, often forcing the user to close it or leading the operating system to terminate it automatically. The core reason behind a software crash lies in the program losing its ability to properly manage its resources or execute its instructions. This can happen due to memory access violations, such as attempting to write to a protected memory area or dereferencing a null pointer, which the operating system views as a critical error. Another common cause is an unhandled exception, a runtime error that the program was not designed to catch and process gracefully. When such an error occurs, the program does not know how to recover, leading to a breakdown in its internal state and eventual termination. Understanding these underlying mechanisms helps us identify why a program fails, moving beyond just observing the symptoms. For instance, an application might encounter an infinite loop, continuously consuming processing power without progressing, eventually leading to the operating system or user intervention. Another scenario involves resource exhaustion, where the program attempts to allocate more memory than is available, prompting the operating system to shut it down to maintain system stability. These instances highlight the importance of robust error handling and resource management in software development. A key distinction to remember is the difference between a program that crashes and one that simply freezes or hangs. A crash signifies an abnormal termination, whereas a freeze means the program is still technically running, but is unresponsive to user input or internal processes. While both are disruptive, a crash definitively indicates a failure in the program's ability to continue execution, often leaving behind valuable diagnostic information like a crash report or a stack trace for developers to analyze. Ultimately, recognizing a software crash as an involuntary cessation of program execution due to an unrecoverable error or resource mismanagement provides a clear framework for diagnosing and preventing future occurrences. This understanding allows engineers to focus on identifying the specific failure points, implementing more resilient code, and ensuring a smoother, more reliable user experience in their applications.
If this helps you fix faster, like, subscribe, and keep debugging with us.